didn't try at all.
You're going to.
I should have tried it.
Oh. That's right.
You can still try it.
So we are going to build these PowerPoints. Everybody is going to build these three slides. The fourth slide is optional if you want to make a conclusion page. You will make a title page. It should say something like interpreting my graphs or something like that, and your name. You will paste an image of your graph from Desmos here and a link to your graph here. You'll interpret the graph. You'll have an interpolation and an extrapolation. And then you'll do it again for Google Sheets. Okay? This is 200 points, just as much as the test we just took. Okay, 100 points for Desmos, 100 points for Google Sheets. To do this, you will return to your data collection and your Google Sheets, right? So those are the things that we've been using to guide our instruction. I'm going to start with Google Sheets. I believe it is a little bit more familiar to all of you. Okay, so remember, Trey's, sorry, I won't say your names. Sorry, I apologize, Trey, but you said that. Okay, so T, A, T, and J, you all still need to do this part. Okay, so 20, I'm using the data that we used for Jerome. I gave you all Jerome, the data from Jerome. So here, this is the data Jerome generated, and I'm going to make sure I have my data in there. What'd you say? So the hallway group, make sure you're doing this. You have yet to do this. Okay. Type of tennis ball, I'm going to do this now, the percent drop, okay, because it'll be recorded and you can go back to this later. Remember, the comment I wrote, this column is telling you what percent of the initial drop does the ball bounce. So what I need to do is ask myself, how do I get that value? So what percent of the initial drop is the first bounce? So I'm going to say this equals in computer science is different than equals in mathematics. This is extremely important, which is why I'm standing on my chair. An equal sign in mathematics is a relation. It's relating and comparing two things. An equal sign in computer science means computer do something. An equal sign in mathematics does not mean human do something. An equal sign in mathematics is comparing two objects. 2 and 3 are the same as 5. 2 and 3 are the same as 1 and 4 when we add, okay? They're showing relations, not commands to do something. Like when you hit the equal sign on a calculator, you're telling the computer to do something. It's different, okay? So here I'm typing an equal sign because I want the computer to do something. What I want them to do is I want to find the ratio of the bounce height divided by the drop height. I hit enter. It's going to suggest to autofill, yes, please, salud. And then I want to change these values to percentages. So this is saying that these are the percent of the original drop height that the bounce height returned to. Now, if I find the average of these percentages, it's going to give me the average percent that ball returns. So I'm going to say equals AV. It's going to say, do I want to find the average? Yes, I do. It's going to ask me, do I want to find the average of these cells? Yes, please. I can hit tab, and it calculates that for me. Maybe I don't want the average. Maybe I want the median. I can do the same thing. These are other options. You can find the median of them. These are different measures of center that are important to interpret. Or I can find the mode. Okay, equals mode. And then it'll suggest, what do I want to find the mode of? These. I know I'm going fast, but it'll be recorded. Okay? These are very similar values, but they have variation. They're not all exactly the same number. So this tennis ball reaches about, 78 to 80% of its original drop height. Now I want to make a regression from a scatter plot. New word, scatter plot. Everyone say or think, you don't have to say it if you don't want to be recorded, scatter plot. Scatter plot. Yes. So I'm going to insert a chart. And it knew that I wanted a scatter plot. Not always does it know. If it didn't come up with a scatter chart, you're going to click over here and find a scatter chart. Okay, I want to save this. Won't let me. Maybe I can control copy. And then I go to my Google Sheets. Control V. Link to spreadsheet, why not? Beautiful. Okay, I'm almost like a quarter way through my assignment. But wait a second. Does anybody see a line through those points yet? Not me. Okay, if I were to estimate where I think it might go, I'm going to say something like this. I want it to go as close as it can through as many points as possible. So we'll see if I'm close to what the computer generates. So let's see. So I'm going to go edit chart, customize, series, trend line. And I want it to label it. I want the trend line to be labeled with an equation, and I want it to show R squared. And I think it jumped a little. But was my line close? It was close, but it wasn't perfect, right? Everyone check out my line. I know y'all are either zoning in or out. That's why I'm recording it. It's okay. My line was a little too steep. Everyone say steep. Steep. Everyone show me steep. Now make it a little more shallow. The computer found that the regression line was more shallow than I thought. Okay? Now my equation is here, and this tells me that it's 99% accurate. The R squared is 0.99. Trying to yell into the recorder. So it's a really good regression line, and that's the equation for it. Okay, so I'm going to do that again here. This is my R squared. It's called a correlation coefficient, and it's 99% accurate. This is a good regression line. And then this is the line it gave me. It says 747 thousandths times x plus 813 thousandths. And we'll dive into what that means later. Okay? This is the graph you want because it has the regression line. So now I'm going to paste this on top because I want that one instead. Deep breaths. Okay, so then I'm also going to share the link. Paste it here. Okay, and then that's done. I'm only going to do the same thing for Desmos. We'll talk about interpolate, extrapolate, interpret later. So now I do the same thing for Desmos, okay? I go back to my Desmos calculator. I should be able to open my recent graph. Here it is, open graph, because I signed in. I hadn't updated the data points yet. I will copy them from the Google Sheets. Delete this, click, paste. There's the same graph, but now it's on a different platform. And this is super dope. Ready? So we're going to do Y. This is a tilde. Instead of using an equal sign, we're using a tilde. The tilde means find a regression. What am I finding a regression of? Of the values above. So what I want it to do is find the regression of m. Well, we'll do a, x1 plus b, and I need to tell it y1. %99 correlation coefficient. My coefficient of x is 747 thousandths, and my y-intercept is 813 thousandths. So if I wanted to graph that line, it'd be y equals, I can round 0.7, I'll go 75 x plus 0. I'll just do 8. Okay? And then I can go into the settings of this line, and you can change it if you want it to show the equation and such. Okay? Then I can go to share, export image. You can choose how you want your image to look. Download. Go to your slides, insert image from computer. Go to my downloads, Desmos graph, enter, boom. Then I add my link. I'm going to crop this instead of minimizing it. And then I just need my link. And that's how you build the graphs and get them into your slides. Okay? And we will do interpret and interpolate and extrapolate later. Okay?